Hi, my name's Peter Wilson. I'm a researcher here at WMG, and I work in the Sustainable Materials and Manufacturing group here. I've got a slightly ominous title to my talk, Carbon Fibre, A Black Future. So it's kind of got a little bit of a talk about, the future of carbon fibre and what we're doing here at WMG. But really, to explain a bit about my talk, I'm just going to go through my history of how I've got to here today to go and tell you about it and all my research. So, first thing to talk about is back when I was 5 years old. My favourite thing to do was play with Lego. Anybody else? Good show of hands. Fully agree with you. Still enjoy doing that if I can. Anyway, my favourite things about Lego was that you could break it apart, you could find out what was going on, and I kind of absolutely loved that kind of part of life, just pulling things apart and just finding out what it was made from. So all in all, when I got to school and started learning about science, that really fitted with my kind of personality. I just wanted to find out everything about how everything was made up. And all in all, that led me to be really interested in chemistry. I absolutely loved learning about the kind of molecules which make up everything. From this, the other science which I was really fascinated in was physics. I was very, very interested in what was going on there. I've learned a lot about energy, and got to find out, this is kind of the first point where I really got taught about environmental impacts of making energy. We found out there was a lot of bad ways of making it, using some of the coal industry, but kind of an essential necessity to make sure our lives work well. But also there were some other good methods of using it, such as the sustainable and renewable methods, such as wind turbines, solar energy. We're able to generate lots of power and keep our lives, working well. However, from this, it also linked into the other really important thing I learned in physics, and something which actually was going to shape my life in the future, which was just this really simple relationship between the mass of an object and how easy it is to move. If something's really heavy, it's very, very difficult and requires a lot of energy to move. So when we take that and apply that to things like all of our mobility, such as planes, cars, boats, all of that, if we make our objects really heavy, they take a lot of energy to move. And that has a negative impact on our environment, which is a dreadful thing. So all in all of this technology which I'd learned at school all really led me up to wanting to do a degree. So I picked material science as my degree because I just still had that fascination of what everything's made of. So I can't tell you the whole degree here, but in a short slide summary, one of the key things you learn as a material scientist is that you've got to pick the right material for the right application. We know a lot about the steel industry, which was fantastic, and Russ has already told us how fantastic steel is. We've got to find out how amazing they are at high temperature and how strong they are and how they can be machined. Another part which was particularly close to my heart was the polymers industry. It was really fascinating to know that we could be making parts at really high speeds, faster than any other process going out there in the world. We could be knocking parts out really quickly, and they could go into objects all around us. Beyond that, another industry which really fascinated me was glass science, a completely disordered material structurally. But suddenly it's able to hold wine in a glass, but also it's able to take waste from nuclear power plants and make it safe. Absolutely fantastic. The final part, which was shown up in our degree with quite a lot of regularity, was ceramics. So I put this picture up here of a circuit board, and inside some of those chips there are ceramic components to enable special electronic kind of bits to work. But as Russ had pointed out when we were doing this work, that picture actually shows a perfect application of what we were talking about before, the right material for the right application. We've got bits of steel wire in there, and we've also kind of got polymers surrounding some of the components, and as I mentioned, ceramics in there. So it's a perfect example of picking the right material for the right application. However, what usually gets me going is when I don't know something. I love to find out about new things. And one of the things I was asking some of my course mates was, what is a composite? I had absolutely no idea. We'd not really discussed it in any length of detail, and I was 2 years into a degree. Conveniently, I didn't need to wait that long. But I guess let's open this out. Does anybody in here know what a composite is? A composite material really is a mixture of two materials coming together. And the benefit of that is that you can gain properties from both sides of those materials to make something better. So an example of this is something like putting steel reinforcement inside concrete to make it perform much better than it would have done before as just concrete. Or another example of this is this guy here, carbon fiber. So this is where we take structural fibers and we mix it with glue. Essentially, the epoxy you mix to repair things when things are broken at home. We mix those things together and we make plastic, which is no longer acting a bit like a plastic. It's much stronger. And the nice thing about it is it's very, very lightweight. Another part of this is that they're incredibly easy to produce. We can produce a lot of these at room temperature and sometimes just a little bit hotter than that. So it's a nice positive to them. They don't take much energy to produce. One of the comparisons with composites, which isn't frequently talked about, is that a composite is pretty much closely related to a wood. The idea with wood, and it has the same design philosophy as wood. With wood, the way we kind of work it is that along the when you take a plank of wood, the fiber runs along the direction, so the grains of the wood are all aligned, so making it very strong in one direction, but very weak in another direction. From this, if you take this design philosophy, which is the same for composites, we can put strength only where it's required. So beyond it being already a lightweight material, which is fairly strong, we can only put the strength where it's required, further minimizing the weight. All in all, this leads to lots of products, such as sporting equipment, which I've put up one of my personal favorites there. I'm a kayaker. But it also goes into other industries, such as the wind turbine industry, which has made renewable energy much more affordable. Beyond that, and the part which is very close to my heart, is that composites have gone into the automotive and aerospace industry, making our planes and cars much lighter. So then we're able to put less energy into them and make the amount of gas coming out of them, which is bad for the environment, smaller. Therefore, we can have this nice, easy conclusion that all this work I'd learnt about composites, the simple thing is that composites are nice and sustainable. They don't take much energy to manufacture and they can enable lightweighting. However, that led me on to do my PhD, studying all of that. But partway through my PhD, I suddenly had this sudden realization, and someone had kind of questioned us about it. What happens when you've finished with the item? So as Russ had mentioned, steel is 100% recyclable. But composites are very difficult to recycle because they are inherently made of two different materials. It's very difficult to separate them apart and reprocess them. All in all, this completely spoils the whole image I've been driving and pushing my career forwards towards. We'd expected them to be nice and sustainable, but if that's not the case, all in all, they're not really sustainable. So I carried on with the industry trying to work out what I was going to do next. In steps the role of WMG. WMG had worked alongside some entrepreneurs out in the UK, and I had a look at seeing if they could develop the recycled carbon fiber industry. From this, really, we had a very simple goal. It was remarkably simple. We were going to take products at the end of life and the waste, which is from manufacturing. They were going to reclaim the fiber, and then together with WMG and myself, we were going to take that fiber and reprocess it back into a brand new product, which then could go and be recycled again, making the material wonderfully circular and sustainable for the future. Obviously, when it's drawn up on one slide, and it looks very simple. However, as with all these things, they're not very simple to do. On the left-hand side, we've got a nice picture of a flaming plug, and that's really to symbolize that one of the wonderful things about carbon is that it's conductive. But that means when you're processing it, it starts to want to jump into the circuitry which makes your machine and therefore cause short circuits, which we saw what happens to batteries when they short circuit. So all in all, it's really difficult to work with. So we had to put a lot of work and effort into making sure that the carbon fiber could be processed safely within our labs. Beyond that, the other major concern for when processing this is, like before I mentioned, composites are a bit like wood. On one direction, they're really nice and strong, and on another direction, not so strong. So this is a bit like when we recycle them, it's a bit like you took your piece of wood, chopped it up into lots of pieces and made sawdust. And now you have to recombine that all together to make another plank of wood. It's never going to be as strong. So we had to come up with some novel ideas on how we were going to get this all back together. The main method we used was working with the company. They basically built a machine which was an enormous comb. Essentially, they combed all the fibers, so they went into some level of alignment, and they started to reassemble basically back to our tree. From that, they gave us the material, and we started processing it using traditional techniques. So up there on the right-hand side, that's actually a picture from our lab. What we did was we placed that fabric inside of a bag, drew out all of the air of it, and placed through a polymer going through it. It's a bit like, the process is very, very similar to if you're drinking a juice through a straw. It's exactly like that, and basically we end up with a product which is exactly like this guy. So this is a recycled carbon fibre laminate. Impressive stuff. Another method we used, and one I started on, was injection moulding. We borrowed the processes from the plastics industry. From this, we were able to take short fibres and bits of polymer, combine them together into a machine, and make complex parts out at the other end. This was really, really good. To talk about injection moulding, it's a bit like as if you took a tube of toothpaste and squeezed it into a mould to make a shape. It's pretty much that thing. It kind of pushes forwards and you can end up with this big molten blob, which turns into a complex shape like that. All in all, it was quite a nice story. We did a lot of process development and things got better. We in fact made some materials and some demonstrator parts as shown there in the centre. And the nice things about it were, in comparison to some of the other materials out there, we were able to make them much lighter than before and much stronger, which was beneficial. And they were a nice cost saving, which was also another good sales point to talk about. It was fantastic. We'd managed to make something which was lighter, it was cheaper and much more sustainable. From that, we went as far as making a submarine out of it. And we took that over to, I don't know if any of you have been on the tour of our workshop just over there, but there's a submarine currently set there. It now doesn't look the same, but it's the same hull underneath. So we actually made that out of recycled carbon fibre and won an award, which I'm very proud of. However, I'd like to say, that's it, end of story, we've solved it, that's it, done. But that's not the case. We've got to a point where we've worked with the company, we've managed to reprocess things, but it's still not as good as the original material. There is work in progress to happen. From that, here at WMG right now, we're looking at other methods of applying this recycled material to kind of push it out and make it a much larger market. So the things we're looking at right now are we're looking at the electrical conductivity, trying to turn the negatives of what causes us problems to process it into something which is a positive. We're also looking to see if it's any good for transferring heat. And beyond that, a recent project we've been involved in is to see whether it's possible to absorb the vibrations and make cars which are less wobbling around, which is really, really useful. And the final thing, a personal project of mine, is to see if we're able to make moulds out of it. So see if we can take this recycled material, make a mould, and then we can make more parts out of it. It's all a nice thing we're working on. Hopefully you've seen that although there's kind of a big nasty problem of recycling, you can see that WMG and the research we're doing here has made some steps to improve it. If you've got any questions, I'm happy to answer them, and you can catch us on AskWMG, the hashtag there. Thank you for your time.